Now, I actually want to have a look at this similar triangles question that you'll come across, because this little question requires us to use some of the algebra that we've learned in previous units to actually be able to solve this. So let's have a look at this question. So it's saying in the figure below, the length BD is equal to 20 centimeters. So that's just saying that this length here all the way across is 20 centimeters. So we can just add that to our diagram so that way we don't forget it. We need to establish that the pair of triangles are similar. So the two triangles I can see we've got here is the larger triangle ABD and the smaller triangle RECD. So we've got to establish they're similar. We don't know that they are yet, and we hence need to find the length of X. So you can see here that between our side length CE, our side length ED, we've actually got X written there twice. We need to find the side length of X in particular, but we could also find ED if we found X. But step one, we need to establish that these two triangles are similar, and this one's a little bit tricky. The first angle that are the same between these two triangles is pretty easy to spot, in that they do share that little vertex there, that, you know, the angle at D. So this is what we can say here. The angle at D between the larger triangles, so it'll be between A and B, that angle there is actually going to be equal, the same as the smaller triangle, so the angle at D again, this time between C and E. Now, because they share that spot, we call that a common angle between the two triangles. So, the next one, it's actually given it to us. So it's kind of like, it's tricky because of the rotation, but it's actually given it to us. It said that the angle at the vertex B here, it's told us is alpha, and the angle at the vertex E here is also alpha, so that's what we can actually say here. So it's the angle at B between A and D must be equal to the angle at E between C and D. And our reason here is that piece of information was given to us, so we can establish it like that. And because of that, we can therefore say that these two triangles, so triangle ABD, must be similar to triangle, what's the smaller one, CDE. And the reason, they're equiangular. So that's step one done. We have established that these two triangles are in fact similar. What's tricky with this is actually understanding how they're similar. How is one a enlargement of the other? Because even if you just look at the diagram, these diagrams aren't drawn to accuracy, but even if you look at it and you tried, you know, enlarging this triangle CDE in the orientation that currently is, it's pretty clear it's not actually going to fit and become triangle ABD. So when we look at corresponding sides, that's where the trick is a little bit. If you think about this smaller triangle, that angle there has to correspond with that angle there. So what this means is if we rotated this triangle, it's you know, the triangle's going to stick out here somewhere. So it's not a rotation, it's actually a flip and a rotation both together. So we've kind of flipped this triangle over and then fitted it into here. And that's the reason why this angle ends up over here. So when we start thinking about corresponding side lengths, that's where things become a little bit tricky. We've got to start thinking about it, because on the smaller triangle, if we've flipped this smaller triangle C to D was actually corresponding between A and D, as was the smaller side E to D, because we've flipped it, that actually corresponds with this side over here, B to D. Now, E to C does actually correspond to A to B, so that one's a little bit nicer, because when we flip it, it's still going to stay over here. Now, that's important to note because we need to use our angle theorems to be able to, not angle theorems, we need to use our properties of similar triangles, the fact that the ratios are going to be the same as each other, to be able to solve this. So the first thing I look at is my angle, the side length EC or CE, whatever you want to write it as, because that's the side length we're after, and that corresponds with the side length AB on the larger triangle. Now, because I've gone smaller triangle divided by larger triangle, it's very important I stay the same way the whole time. The other piece of information I know is the side length DE. because that was given to us. Well, we kind of know it anyway. It's x plus 2. And that corresponds, like I said, to that actual side length down in here because it's a flip. And that's something that's really tough to think about. You've got to flip it over in your mind, and it actually corresponds with that 20 centimeters over here, which is the side length BD. So now what we can do is we can substitute the information we have in here. So side length CE was X divided by AB, which was 12. And that's going to be equal to DE, which is X plus 2. And that's divided by BD, which is 20. So suddenly what we have here is we have a bit of an algebra problem that we've seen in a previous unit where we've had to solve X, where we've got an unknown on both sides. Now, we're solving it when we've got fractions. We could try and find the lowest common factor of our two denominators, but because I've got the unique situation where I've got a fraction divided by a fraction, I can actually just shortcut this by cross multiplying. You just got to be very careful when you choose to do that, because so that's going to be 20 times the x is equal to 12 times the other side. And you just got to be careful when you do that, because if you have like a plus 2 or something at the end here, you can't just cross multiply anymore. That's just something you got to be aware of. So from here, I'm just going to expand the right hand side. So this will be 20x is equal to 12x plus 24. Now I'm going to get the x's to the same side, so I'll just quickly show the working out here. So if I subtract 12x from here, it means I'd have to subtract 12x from here. So that would leave me with 8x is equal to 24. And then finally, I would need to divide by 8 to find my answer on both sides. So now I do that. I find that my x value is going to be 24 divided by 8, which is 3 centimeters. So that means the side length CE is 3 centimeters, which is what I've been asked to find. Now, if I was after the side length of ED, if that's what they wanted, I'd obviously need to substitute 3 into here, add 2 to it to realize that the side length of DE would be 5 centimeters in this situation. So just a bit of a trickier question when we're looking at similar triangles here. It does use a little bit of algebra, and I kind of like that because it starts to mix in some of the skills that we've learned in previous topics into the topic we're currently starting.